And then when time is greater than 1, what will happen now is, right, so the minor web will carry all the load, distribute the load, right? And then the fastener, which I'm going to draw now, right? So once it occupies over here, right, it's occupied, the shear flow, it's called a shear flow, it's like fluid flow, right? The shear flow have to go somewhere. So the nail or the fastener will transmit, okay, transmit the load, okay, will transmit the load now. So the fastener now, right, will transmit the load in, I'm going to color in blue, right? The fastener will transmit load. Then after that, what will happen is the flange, right? Okay, the flange will distribute the load. Okay, it will, let me, I'm just rushing, I should be patient. Flange will distribute the load. Okay, so now to take all of this into context now, okay, we have to find the first moment of area of the minor webs and the flange. Okay, so I'm going to again take this diagram. Okay, so we are going to find the Q. Now, if you have any question, speak up. Okay, as I said, I only have one computer. I cannot look at the chat. And if any of you type in the chat and those with the mic, tell me, Eugene, there's a message on the discussion. Okay. So Q now is at point D, right? Is equal to twice the Q of the minor web plus by Q of the flange. Okay. So this will be equal to twice. We found the minor web to be equal to how much? To be equal to 6, right? Is it 6? Let me see. Yep, 6. Okay. And then we have to plus the Q of the flange. Okay. So the flange, the width is 10. The depth is 1. The Y bar, let me go to the Y bar, is equal to 3.5. Okay, you can see that it's 3.5 minus by 1 divided by 2. Okay, so this is 12 plus by 3.5 minus by 0.5 times 10 times 1 is equal to 30. Let me do it again. 3.5 minus 5.5 times 10 times 1 is equal to 30. So this is equal to 42-inch cube. Okay. So from here, we know that the shear flow V or Q, small q, is equal to Vy over Izz Qz, and this is the force divided by spacing S. Okay. So if my memory don't fail me, is 4.5 times 10 to the power 3. Qz is equal to 42. Izz is equal to 410.5. And this is F divided by S, which is equal to 3. So our F over here is equal to 4.5 power 3 times by 42 times 3 divided by 410.5 is equal to 1381.2 pound force. Okay, let me do it again. 4.5 power 3 times by 42 times 3 divided by 410.5. 1381.2. Yep. Okay. Rachel, is this better now?
Hi, yeah, that explains, but I was just confused the way you did QD in the question, like the printed version. It said 3.5 times 12 times 1.
Yeah, don't follow. I mean, it's also correct. I'm not saying wrong, but the method that I teach you, right? It is, sorry, the answer is also the same. Okay, but when using this method or this way of looking at it, you understand better. Yes.
Yeah, this way is
Yeah.
better.
So apply what I teach. Okay, this is also correct. The answer will also come out to be the same.
Mm-hmm.
You can see that, right?
Yeah.
Okay, but the way I teach is based on failure analysis, based on the shear flow. Yes or no? Right?
Yeah.
Yeah,
Yes.
based on the shear flow. It makes more logical. Or not, it does not. It does not make any sense why you just take over here, right? Right?
Yeah.
Yeah. There you go. You can do it also. I'm not saying that you can't, but you have to think about a concept why that's the case. Okay.
Mm-hmm.
But the answer happened to be the same. Okay.
Thank you.
No, thank you, Rachel. I think it's important to clarify. I did not know that they just take this. I know it's also correct. Okay, I'm not saying it's wrong. Now,
Yeah. So
when
someone asked in the chat
okay,
a question. Sorry, like, yeah.
you know, but Rachel, you're okay now, right?
Yeah, I'm okay.
Okay, one is in the chat. I know this is a bit of a larger content, but can we do a brief run through week 7? Mainly the concept where I mess up, where I suppose most students mess up the most. Okay, so let's look at I have not a clue why it's week 7. Let me look at week 7. Lucia, week 7, which part that you're confused? Can you be more extensive? Is it the one with the shear center, or is it the combined loading analysis? Which one is it? Combined loading. Okay. But okay. We'll do combined loading. Hold on. Okay, we'll do the combined loading. But before we do the combined loading, can we address Chow Tai Mei's design of the shear flow? Okay, very quickly. Okay, Lucy, I don't mean to put you off. Okay, I will, because that one is really, really quick. Okay, so Chow Tai asks, Chow Tai, which homework is that from? Can you tell me?
Yeah, I think it's week 6. Let me check. It's week 6, number
I-
3.
Okay, this is a very interesting, same concept. Okay, Solomon, or I know him as Solomon, is asking a question. Okay, that is the design of the shear flow. That, yeah. Okay, so I'm going to if you look at this question, right? Again, the concept is member distribute load, fastener will transmit the load between members. So what's a member? Okay. So over here, this is member number 1, member number 2, member number 3, member number 4, member number 5. Okay. The shear stress or the shear force is coming down this way. B, and I'm going to call this Y. This is my Y, and this is my Z, right? So if we were to design a shear flow first, okay, we know that the shear flow is controlled by the major web, right? But where are the terminus? The terminus are here because it's wide flange. So when that's the case, the shear flow will do this. And these are the fastener that will transmit the load. Okay. So for this problem, this is the reason why the first moment of area Q is only looking at member number 1. Only. Okay. So the first moment of area only need to consider either member 1, 2, 3, or no, member 4 or member 5. Okay. Solomon, does that answer your question now?
I think so.
Right? Again, this is the question you asked me last lecture, right? It makes sense, right? If you I think how I wish I can explain this in Mandarin. Okay, the member would
Like, yeah, I just cannot understand why it's not a main web, because like for the question number 2, and that would be the flange one and the middle one, right?
wait,
And for
question
this
number what?
one,
Wait. Question number
number 2 from the homework. Yeah, that one is only for the flange, the middle part.
Yeah, that one is only for the middle part.
And
Exactly.
this one is the M1 or M3, either one. But like, I'm so confused.
May, wait. I know where you're confused. The terminus.
Yeah.
I'll show you this one why it's different. Okay. May, the concept is not difficult. I don't think you're getting where the terminus is from. Okay, I think you're almost getting it. Okay. We are going to get a breakthrough. Okay. So for this case, the shear flow or the force, okay, is a good question. If you're going to compare and contrast, the concept is the same. Okay. Is the design part. That's where 3A it's not an easy topic. Okay, it's not an easy topic. You need a lot of practice. Okay, and I know May practice a lot. I've seen his homework. So over here, this is your VY. So this is like a box beam now, right? And then over here, this is where the terminal is now. Then the shear flow will distribute this way. Q. Okay, that is why you only take this section. Okay, whereas the example on the top, where is the terminal? The terminals are not in the center.